In topic 3 of chapter 1, we're going to deal with factoring. And they start off with the number 18 can be written, and you could read this, but I want to go over a technique with you that if you have 18 and you put something like this out there, and you can say, what can I take out of an 18? Well, since it's even, you can take out a 2, and that will give you a 9. And then when you get to 9, you can take out a 3, and that's 3. So what you have here on the outside are your prime factors of 18. And remember, you can always take a 1 out of anything. So what are the factors of 18? Well, 1 times 18. Every number has a 1 times it. Then you can have the 2 times 9. Or you can have the 3 times 6. And keep in mind, to get a positive 18, you could also have each of these as negative numbers. So that's background of what we're going to be doing. Now, as we look at this next little part here, and I'll raise it up a little bit. I can see where my mouse is. There it is. We want to deal with the greatest common factor that may be in a number. So we look at something like, let's go right to our example here. So I'll write it up here. 12p minus 18q. Now, I'm not going to do this the best way first, but just to show you the process. Now, as we look at the letters, there's no common letter. But as we look at the numbers, we see we can take a 2 out of there and get a 6p, and a 2 out of there and get a 9q. So we've taken out a common factor. But have we taken out the greatest common factor? And you can tell that by looking inside the parenthesis and see you can still take a 3 out of there and a 3 out of there. So actually my greatest common factor that I should have taken out of there would have been a 6. So this gives me a 2p. Take a 6 out of there gives me a 3q. So now left in the parentheses there's no more common factor. I have taken out the greatest common factor. And then I can easily check it just by distributing. Now we mentioned that in an earlier lesson that we were going to distribute and then later we were going to factor. And there are some examples here and in your math lab that you'll be doing. Now, when we see something like this, what is the greatest common factor there? Now notice this one is to the third, and this one is to the second. So the greatest common factor for this one is 4x minus 3 to the second power. And then you have what you have left. So some of these get challenging right away. Factoring. Now, when we go to factor quadratics, again, we said that here is a trinomial. We want to find out what binomials were FOILed to end up with this trinomial as a result. So there is a process, and let me set it up for you. So in your homework log or your notes, you're going to write out the trinomial they want you to factor. And you put it in what we call standard form, that is descending from degree 2 to 1 to 0. So this is in standard form. Now, you then look and see, is there a common factor that I can take out of each term? And the answer is no. So your next step is to put two sets of parentheses beneath it. And then you're going to look at this first term here. Remember, it was multiplied by the first of your binomials. And in order to get an x squared, this is one sort of easy. It's just going to be an x and an x. Now, to get your last term, we had to multiply these together, and we're going to get an 18. But here, what we need to do is figure out what are the factors of 18 that when we did our outers and inners will add up to a positive 9. So here you can see a little bit of it, that they're asking you to list the factors that I did above, and one of the sets should be 3 times 6. 3 times 6 is 18, but if you add them up, they add up to 9. So these are our last items, 3 and 6. Then we have to look at the signs. Since these are all positive, these will be all positive as well. And then we FOIL it, and it checks out. So there is the factorization of what we have. Once again, the steps: put it in standard form, see if there's any greatest common factor that you'll pull out, and then undo the FOIL, and then check it by FOIL. And again, you can read what they have here, because all of this is good stuff. Now, let's do another one, and we'll write it out here. X squared plus 3x minus 10. Is it in standard form? Yes. Is there a greatest common factor that we can take out? No. Next step, two sets of parentheses, because we're going to undo the FOIL. X goes there, and we want factors of 10 that somehow have the difference of 3. Well, what comes to mind is a 5 and a 2. So I could put the 5 there, or I could put it there and switch these around. It's no big deal. But now I need a negative sign for my third sign here. So that indicates one of these needs to be negative and one will be positive. And when I look at my middle term, I see that it's positive. So I'm going to choose the plus 5x and a minus 2x to give me my middle term. And I have factored that satisfactorily. Now notice in the book they're reversing these, which is perfectly fine. MATLAB should always accept that. Let's go on and we'll do another. Now here, things get a little tricky. And we'll write it out for you. 4y squared minus 11y plus 6. Is it in standard form? Yes. Are there any common factors? No. So, 2 sets of parentheses. Now here, since our coefficient of y squared is not a 1, I can't just put a y and a y. So this is going to have to be a 4 and a 1, or a 2 and a 2. And as we look at it, we don't know right away. So we're going to do guess and check. So I'm going to... So what I've done is I've paused the tape and I fiddled around with the combinations that could possibly go there. And I said a 4 and a 1, or a 2 and a 2. When I tried the 2 and the 2 and the 3 and the 2 and the 2 and the 3 there, I couldn't get a negative 11 in the middle. So I went back to my 4 and the 1, and then I tried 3 there and 2 there, and notice that if this middle term is negative, but this end term is positive, so both of these must be negative for my last term to be a positive. But now when I do my outers, I get a negative 8y, inners, a negative 3y gives me that. So this technique is called guess and check, or trial and error. So you're fiddling around with this when this coefficient of our lead variable is not a 1. When this is a 1, it's a lot easier, because then you have to start thinking, what are the factors of that? And probably, if I went down here, well, that's the end of that page. Let's get to the next page there. We actually see it. Now notice they're showing us a variety of possible middle terms depending what factors we use. Okay, let's take a look at number 5 here, and I'll set that one up. Now again, in our textbook it's worked out, but let's just say you have to do it. So is it in standard form? Yes. This one is decreasing as your Q's are increasing. Is there a common factor? No. So again, put 2 sets of parentheses, and we know we're going to have a P there, and a P there, and a Q there, and a Q there. This is all background. And also, since this middle term is negative, and this is positive, this one is also negative, one will be positive and one will be negative. But we can wait a while on that. Now, since this number is so big, 5, and this is a 6, I don't think we're going to use a 6 here. But again, that's always an option, a 6 and a 1. So I'm going to try a 3 and a 2 there. Now, once I've done that, 5 is prime, so it's just going to be a 5 there, or a 5 there. And I see it now. It's going to be a 5 there, and a 1 there. We don't put the 1 usually. But can you see this is going to be a 10. Your inners are a 10. Your outers are a 3. The difference is 7. And since this middle term is negative, the larger has to be negative. So that's going to be a negative there. This will be a positive there. Now, if the 3 and the 2, you could have had a 2 and a 3, doesn't work, then you try the 6. But often, if this number is small, this number is small, you're not going to use a 6 there. And this comes with practice as you develop it over time. Okay, let's go on. Now, as we look at this one, x squared plus x plus 3, it's in standard form. Can't factor anything out. You put your parentheses, and it's a 3 and a 1 no matter how you do it. There's no way you're going to get a 1 there. So when there is no factorization that will work, we usually say it cannot be factored, or we say it's prime, P-R-I-M-E. Now, one of the things they didn't show us in the previous lesson is factoring patterns. Let me give you a little background on this. If we were to take A plus B and FOIL it by A minus B, we describe this as the product of the sum and difference of the same terms. Well, these have a relationship. We call these, when it's the same terms but one's plus, one's minus, conjugates. And I would write this in your notes. Conjugates. Now, when you FOIL conjugates, an interesting thing happens. So let's FOIL this. A squared, outers a negative AB, inners a positive AB, last a negative B squared. When you FOIL conjugates, notice what happens to the inner terms. They just cancel out. So we end up with A squared minus B squared. This is called the difference of perfect squares. Now, if you recognize the difference of perfect squares, they will always factor into their conjugates. So here they're saying there are patterns that can be followed. So for this one, that will factor into its conjugates. So you take the square root of this, which is 2m, you take the square root of 9, which is 3, and 1 is plus, and 1 is minus. And you can check by the FOIL to see if it's correct, and it is. These are conjugates. If you see the difference of perfect squares, they factor into their conjugates. Let's go on here. Now, keep in mind that this doesn't look like perfect squares right away, but can we take out a greatest common factor here? Yes. We can take a 2 out of there and a 2 out of there. Now when we do that, we see we have the difference of perfect squares that will factor into their conjugates. But don't forget, the 2 is part of that factorization. Now here we see not the difference of perfect squares, but the sum of perfect squares. These cannot be factored. Only the difference of perfect squares. Now as we look at letter D, just to give you a for instance, do you see that this is a binomial that's squared? So we can think of that as if it were a squared minus 49, keeping in mind that a is going to equal x minus 2. We can substitute for x minus 2 an a, and then this will factor into a plus 7 and an a minus 7. But what did we say a was? Well, a was x minus 2, x minus 2, x minus 2. Now we get x plus 5, x minus 9. Okay? And they're just showing you the method of doing it. All right, another one that we're going to look at here as we go down is one that I mentioned earlier, which was when we squared a binomial. Square this, get that. Multiply these two together, double it, get that, square that, and it applies. These are called perfect square trinomials. You can recognize that. They're factored into a binomial square. So let me set one up for you. Now, to recognize a perfect square trinomial, both first and last terms have to be perfect squares. Then what's the square root of 16? 4. What's the square root of 25? 5. Now you're going to go 4 times 5 is 20. Double it, 40. So this is a perfect square trinomial. So we'll set it up like so. You're going to take the square root of that, which is 4p, the square root of that, which is 5q, and whatever the middle sign is, that's the sign you use there. And that is the answer. So, recognizing a perfect square trinomial, first term will be a perfect square, last term a perfect square, and then this could either be a negative or a positive. If it's a negative, then that's the sign you use down there. If it's a positive, that's the sign. And then you can use that special technique. Square this, get that. Multiply these together, double it, you get this. Square this, negative this times negative this, positive that. Okay. Now, as you look at letter B, is this a perfect square? Yes. Is this a perfect square? 1 is a perfect square. 1 times 1 is 1. Now, what's the square root of 9? 3. Square root of 1 is 1. 3 times 3 times 1 is 3, and you're going to double it, 6. So if this were a 6 here, this would be a perfect square trinomial, but it's not. Doesn't meet the criteria, therefore this can not be factored. Now, for something like this, notice, is that a perfect square? Yes, this is 13, and this is 4, and that's a perfect square. So this can be factored. And it is a perfect square trinomial. So now they're asking us for a little mixed practice. Let's see what we can do with example 9. And again, I'm showing you the techniques here. As we look at this next one, we're wondering if we can factor that. So let's write it up over here. 12x squared minus 26x minus 10. Now, is it in standard form? Yes. Is there any common factor we can factor out of it? Yes, we can factor out a 2. And so we get 6x squared here minus 13x minus 5. Now, we then put our two sets of parentheses, and we want to go through this. Now, from my past experience, I don't believe that we're going to use a 6 and a 1 here. I think we're going to use a 3 and a 2 there. And 5 is prime, that works out. 5 goes there, and a 1 goes there. Because what I saw is a 3 times 5 is 15, and then this is a 2, and the difference is 13. So where would my signs go? Well, I need a negative 13 in the middle, so the larger one, this will be a negative 15. A positive 2x gives me my negative 13. And there is my factorization. But again, this is a skill that you're going to try to develop as you go along. Now they're giving us lots of variety of kinds of things to factor. In letter B, there's 4 terms. But I don't know if you see, if I put a parenthesis around this, this is a perfect square trinomial that will factor into a binomial squared, which is going to be 2z plus 3. So again, if I multiply that the special way it gives me that, minus w squared. Now remember, we could put an a here, and we would have a squared minus w squared, which will then factor into a plus w, a minus w, but our a is actually 2z plus 3. 2z plus 3. And I believe that is the answer down here somewhere. Yep. 2z plus 3, 2z plus 3 plus w minus w. Very good. And then you take out those inner parentheses. Now for letter C, again, there is a common factor of 4. When you factor out that 4, looks like this. And if you rearrange things a little bit so that it looks like this, there you see you have a perfect square trinomial that will factor into its binomial square, and then you just do what we've done above. And they're giving you a caution, which is good about the textbook. Always remember to look for the greatest common factor to factor out first. Okay. Higher degree polynomials. Now, in one of my videos, it actually deals with this, which is the factoring of the difference of perfect cubes and the sum of perfect cubes. And it's had like 5,000 hits, so that one is popular. But I'm going to give it to you live right now. And we'll use different letters. A to the third minus b to the third, a to the third plus b to the third. Now, this is the recipe, and you just have to study it and memorize it, and again, follow the formula. And the rule is, we're going to set up a parenthesis for 2 terms and a parenthesis for 3 terms. So we have our difference of perfect cubes, sum of perfect cubes. First step, parenthesis for 2 terms, a parenthesis for 3 terms. Now we're going to go for our signs. Well, in the 2 term, we use this sign right here. So this is going to go right there. Now, if this is a negative, then our middle term out here is going to be the opposite sign. So this is all part of the recipe. Now, we take the cube root of this, which is a, the cube root of this, which is b. And it's the same down here. Now we square this, and that goes right there. Now we multiply these together, disregarding the sign because we already know the sign. This is going to be an AB. And we're going to square this. And notice we get the same results. So once again, difference of perfect cubes, sum of perfect cubes. Parenthesis for 2, parenthesis for 3. 2, 3. Whatever sign is there, goes there. Opposite sign is our middle term there. Square this, multiply these together, square that, and the rest is all the same. So in doing this one, parenthesis for 2, parenthesis for 3, going to put a negative there. Cube root of that is k. Cube root of 8 is 2. And then our opposite sign here. This is going to be k squared plus 2k. And this is plus 4. Now again, we're saying to multiply, but since the sign has already been determined, we ignore that. And you'll get practice on these. And these are worked out that you can try them out for yourself. All right, let's take a look at example 11 because that's something different. So as we see it, again, no greatest common factor that can be pulled out. So to get our first term here, it's just going to be x to the 4th, x to the 4th, a 3 and a 1. We're just going to add them up like so. We FOIL and we get it. And that's what this one is. Now, this one's a little tricky. This is the difference of perfect squares. So this will factor into its conjugates. X squared plus y squared, x squared minus y squared. Now, if you left it like this, you wouldn't get credit for it, because this is still the difference of squares that can be factored. The sum of squares cannot be factored, but this can be factored into its conjugate still. X plus y, x minus y. I have to erase it, so we're going to go up and see the answer there. Right there. Okay, almost finished. So here, these are both squares here. So you would factor it initially into this, and then keeping in mind this is still the difference of perfect squares. Now, on your blue sheet, if you only went this far, I'd give you partial credit. MathLab would count it wrong, but I guess we instructors would give you partial credit on that. And then, of course, into the exercises. Now, hopefully you're keeping good notes in your homework log, because that will be critical for your study and your preparation for your test.